All right, welcome everyone. We're back with another Infinite Layers. This is number 2 in 2 days. I'm very excited about what we're going to be talking about today, there, because this is something that I'm going to be able to play around with a lot, and it's going to really expand what people can build on EigenLayer. And one of the things that I'm very excited about is just being able to kind of like 10x or 100x the number of products being built. And the way that we do that is by offering better developer experience. And I'm excited here to talk about WAVS, which is built by a team whose aim is just to do that. So Jake, can you give us a quick introduction to yourself and then just maybe give a quick also intro to your product?
Yeah, I'm Jake. I'm technically CEO at this company called Layer, but I like to think of myself as more like an artist type. And I've been really interested in crypto for a really long time, ever since I heard about Bitcoin Pizza on Reddit. Read the Bitcoin Pizza story when that came out. So I've been into crypto since like 2010, very long ride. Recently, I was in Cosmos, helped launch a couple Cosmos chains, made some DAO tooling with a project called DAO. But I'm very happy to be back in Ethereum. Ethereum is near and dear to my heart. That's me. And WAVS, what's WAVS? It's a WASI AVS runtime. So we'll get into that in a bit. But it makes building validated off-chain services a lot easier.
Okay, awesome. Succinct intro. I would say you're downplaying your background a little bit. You all have done quite a bit and have a really, really rich background in software engineering and also shared security kind of, I would say. So it's exciting.
Oh, yeah, there's the whole mesh security thing. Yeah, I totally forgot about that.
But yeah, I mean, so we're really excited to have you building in our ecosystem. So I guess if someone was to ask like what WAVS is, that's what we're here to talk about. What would you kind of like explain to them? You gave a very succinct intro, but if you wanted to kind of dive a little deeper.
So WAVS is basically, first thing it is it's a WASI runtime. WASI stands for WebAssembly System Interface. So this allows you to write like little programs that are very efficient to run. You can write them in many different languages. We currently support Rust and Go. We have TypeScript on the way. You can write these little programs and then like just dynamically deploy them, and they can run your like off-chain services. The great thing about WASI is it gives you access to all the stuff you can't do with smart contracts, like GPU and networking and IO and file storage and all those good things, the things that we need to build real applications. So I think a lot of what WAVS is about is like leveraging the latest and greatest in WebAssembly technology so that we can build like more interesting full stack decentralized protocols.
Absolutely. So what that means for the, I would say, analogy with building on EigenLayer with as an AVS, there's just a lot of underlying complexity that kind of goes into actually shipping an AVS to mainnet. You have to deal with a lot of things around operators. You have to deal with slashing. You have to deal with verification logic. And there's just quite a few moving parts. And it's an area that we're obviously investing in improving. But with WAVS, it kind of abstracts away a lot of that. So you can really just focus on your core business logic and get all of the properties that you would get from something like EigenLayer.
Exactly. So like things that WAVS handles for you is like listening to events on different RPCs. Like many people are wanting to build. Great things about AVSs, I think, is that they're multi-chain or like interchain by default, right? Like you can have these services that can serve customers across many different chains, right? So WAVS handles listening for on-chain events from many different chains, including like any like EVM RPC. We also support Cosmos chains. We have Solana SVM on the way, Move, things like that, right? So all that logic around having to listen to different events on different types of RPCs handled for you. You don't have to code that yourself. We also support cron triggers. So that's like a scheduled kind of thing. So like every 30 seconds, run this workload or update this oracle. We are going to be supporting off-chain triggers at some point, but that we don't quite yet, but that's on the roadmap. And then on the other end, we support a lot of the submission logic. So for example, the cryptography aspect of building an AVS is pretty hard, right? We have to run the AVS, then we got to sign the output with the operator key, right? And use the right signature for, then we have to aggregate the signatures, right? And then we have to submit the result on chain. So there's all that logic that you have to build as part of your AVS that's not related to your core functionality at all. And the great thing about WAVS is we let you write like a little WASI component. Oftentimes these look like one file basically. And you write a little WASI component and then you can upload it and it starts running.
So one of the things that I'm excited about is that you all announce the product today. The documentation is live, but you also have so many reference architectures. So if you want to build like an Oracle, or if you want to build a variety of different things, you don't have to kind of like come up with that from scratch. You all provide examples, which is pretty nice. And what we're going to be diving into today is a live demo, which is going to be my favorite part of this. And hopefully the demo gods treat us well today and things work. But I've seen this demo a couple times and I've even built it myself and it works pretty well. Like I've never run into any issues.
We're going to run a new one today.
Oh, let's go.
I'm constantly like churning out new demos. Yeah, let's give a quick tour so where people can figure out how to like find all this.
Okay, cool. Let's do it. Yeah. So we're going to, go ahead, share your screen. If you want to check out WAVS, like I said, their docs are live. You can go to docs.waves.xyz, and WAVS is spelled WAVS.
Yeah, WAVS.xyz. We're looking at the site now. Hopefully.
Yes. I see it. That's good.
And yeah, my computer is definitely freezing up, so I'm gonna stop sharing real quick.
Okay, cool.
This is I expected to encounter the demo gods and not the screen sharing gods.
We'll figure it out.
I've never used the software before. All right, I'm just gonna do like the entire screen because that seems to be easiest.
Right, can you see it? I can see it now.
Amazing. So today we've now got waves.xyz, which is our new website. My computer is really messed up right now.
I think you need a Mac. Are you on a Mac?
I am on a Mac.
Oh shit. I don't see that often on Mac then.
Yeah, that's really great. It's probably all the Docker stuff I've got running in the background. Maybe, I don't know.
We're not in any rush.
Cool. All right, well, can you see this?
Yes, I can see the code. Let's
just go to the code. We have the marketing materials. They're at wavs.xyz. Let's just like check out this example. So this is a new one, and it's called WAVS NFT, and it's an example for making AVS-powered dynamic NFTs. And what is a dynamic NFT, you might ask? Well, it's an old idea in crypto. The idea has been around for quite a while, but these are NFTs that can like automatically update based on like on-chain events, now that we have WAVS, we can even have off-chain events that might update NFTs. So in this example, we're actually going to have an AVS minted NFT. So we're going to basically pay a contract some ETH. It's going to emit an event that is going to cause a locally run model to run. And then we are going to get a new NFT minted for us on chain. If that makes sense. So we're going to trigger an event. We are going to run our WASI component. The operator is going to sign the output. That is going to be submitted on chain, and it's going to be fun. So I already ran a lot of this. These code examples are open source. They're linked to you from the docs. Please check them out. We're also very open for feedback. And yeah, well, let's just run this one first. I already ran a bunch of stuff. So I am running WAVS and a local instance of Anvil, and then also like an Olama model that's on my computer. So it's like we're peering into the window of an operator here. Cool. All right, so the first thing we're going to do is just like deploy our contracts. So we have two contracts. One of them is a minting contract, and the other is a NFT contract. The NFT contract is really simple. That's going to get the result from our AVS and validate it. And then the minter contract basically also has an AVS component, but its main job is to just emit this event here. Like it's going to take some payment and it's going to like emit an event. Now for Waves, any event can work to trigger a component. We'll cover this in a second when we like deploy a component. But here we've got this minter contract with this trigger mint function that's going to emit the trigger. And then we have our Waves contract. All you need to do on the smart contract side to receive data from an AVS and verify it is you implement this simple handle signed data interface. This is called when the aggregator submits this aggregated signatures on chain. Then you get your data and you get the signature. We make it very easy for you to deploy an AVS with EigenLayer. So we got this EigenLayer service manager contract here. And we just call validate on that data and signature. And we know that that data was signed by the operator set of that AVS, if that makes sense. And then simply we like just decode the results and we mint a new NFT and we emit an NFT minted event. And that's really all it is on the smart contract side is literally you can use any event and then to verify a submission from the AVS, you need to implement this handle signed data method. Is that making sense so far?
Yes.
Cool. All right, sweet. So now we get to the more interesting part where we can deploy the component. I'm actually running a local instance of Anvil with EigenLayer and everything deployed on it. So we're getting, yeah, I should have practiced this more beforehand. But like, yeah, so basically we're gonna now deploy the component and there's a couple of different parameters we have when we deploy this component, right? You can kind of think of Waves as like a meta AVS where we can have many AVSs running on a single validator set, if that makes sense. So when we deploy a component, like some key parameters are like the trigger event, right? So in this case, our trigger event is this AVS mint trigger, and then we're going to pass in the event signature for that, right? The other thing that we need is the service trigger address. So in this case, this is our NFT contract. And when we deployed it, we're just like grabbing it with the JQ from our deploy scripts. And we're getting that NFT contract address and the minter contract address. So yeah, all you need to know when you deploy a service, you have to think about what is the event that you want to trigger the thing, which contract is triggering the event, where are you submitting the results. So you have like basically a trigger event signature, the address of the trigger, and then the submission address as well. There's actually a ton more options, so we can actually look at those. I don't including multi-chain options. So you can actually have an option like I want this trigger on this contract on chain A to submit to a contract on chain B. And if we run the make CLI command or the Waves CLI commands, you can see that Waves has a ton of different options, which I'm not going to cover today. I'm just going to try to be focused. All right, let's just deploy the component. And then I'm sure we can have an interesting discussion at the end. Cool. So that just deployed our component and now it's registered and we are going to now trigger the AVS and mint an NFT. Oh, wait, before that, though, we should probably look at the component. So this is an autonomous artist component. It's being built out. We have a few more features coming, but this kind of shows, like, in general, like a more complicated component. They actually can oftentimes be very simple and like one file long. If you look
when you
at
say component, this is kind of the business logic or the unique code for this product or this project, right?
Correct. Like, yeah, that's this is like the WASI component that we're going to compile, and that's going to run the off-chain logic. So this is basically all the AVS logic that you need to do right here, right? The idea with Waves is that, again, we try to handle like all the logic around listening for events and like signing output and aggregating signatures and all that complexity. We tried to abstract that away from people so they can just focus on their pure application logic.
Perfect.
Cool. So here I'm using the Sol macro. The Sol macro is great. You can actually use it with a file as well. So if you have like an interfaces file with all the different types you need, here I'm just like kind of defining, you can actually just write Solidity inside the Sol macro. I'm defining all the types I need for this example here. Here we've got basically the, we're decoding the trigger. So we get a trigger from the component, and that could be an ETH contract event, or components can call other components. There's like actually a ton of features really supported, and it's hard to cover it all. But basically, we are like decoding this event into this AVS mint trigger. One of the things we also support is things like async. So what this block on function is doing is just like allowing us to like run like an async function inside of this, which is super cool because now we can do things like make network requests or open up a WebSocket and listen on it for a while, or we'll do anything that requires async. Maybe we want to like query the chain and like get someone's balance, and then maybe like make their NFT look different if they whatever. So yeah, this is like doing a bunch of stuff, and we're making an NFT. It is actually querying a deterministic instance of Ollama or Llama. So this is a Llama model. We've been playing around a lot at Layer with this kind of a side tangent, but we've been playing around a lot with like deterministic like LLMs, which you can basically use to make an AI oracle, where you could have 10 different nodes, right? And as long as you hard code the seed and enforce a hardware requirement on the AVS so that everyone has the same graphics card, you get deterministic output, which I can show you in a bit. All right. Cool. All right, we're back. So now we're ready to run this. So I've got a script that's going to pay the Mincer contract 0.1 ETH and then ask it a question. This is like a haiku kind of formula. So we just immediately ran it, and we saw the process like kick off in these logs down here. We can actually run it again. It was fairly quick. It took 1 second on this CPU, but like, let's see. Now we can like actually just like get that token URI. So this is actually the NFT that we just minted, which is like, we asked a prompt how to become a great engineer. Great. So we just like auto-generated an NFT like via an AVS.
Nice. And then the content on the NFT was generated from an LLM.
Yeah. So we could just be like, I don't know, what kind of question should we ask this haiku?
Yeah, so we can basically ask anything, and the NFT will be minted based on the LLM.
How do I become a great token, or how do I launch a great token? How about that?
Okay, cool.
Cool. So
see what you just did is like, imagine trying to build a system like this from the ground up. It just would literally, I mean, take an enormous amount of resources. And this seems like a fairly straightforward demo, and it kind of is, but the ability to kind of just have most of this logic encapsulated in that one component is actually crazy.
Yeah, it's pretty out there. Yeah, I think WAVS is cool. Yeah.
Awesome. So in that demo that you just showed, is that open source somewhere as well, or?
That is open source. So let me try to present it one more time.
Cool. Yeah, maybe we dive into your GitHub and docs and stuff for a quick second.
Yeah. So
is your computer frozen up pretty good?
My computer is, something's really wrong with it.
Maybe I'll share my screen, actually.
I think that sounds great. I don't know. It's like, I'm very flustered now because like
it's all good. The demo went well. We were able to kind of walk through the code.
Next time I'm gonna pick one I've like run before, but yeah.
Awesome. So here's the WAVS docs. These went live today. This is like the most recent up-to-date version. There was like a previous version, but this is kind of where the official launch is happening. So everything is really, really nice and redesigned. And over here on the left-hand side, you have this whole walkthrough of how to build a Oracle, which is pretty nice because it really is a very simple and straightforward example, and it really helped me grok kind of like how this all works. You're essentially calling an API, and it's bringing back that value, and then you're kind of bringing it back on chain. Here on the left hand side, though, are kind of like the bread and butter of like developer resources. You have awesome waves here. You have the Waves Foundry template, which is kind of what you get started with, I believe, when you kind of generate a new Waves project. Is that correct?
Yeah, it's like basically the Oracle example,
Oracle example.
which has a lot of
Waves.
so
Oh, it looks like the Waves GitHub link is actually broken. So
okay,
we need to
well,
fix that.
I think the demo repos is like, we're constantly, this is the first time we released it, so
Yeah, totally. Just something to heads up. But all these other links take you to the GitHub where you see a bunch of demos.
Yeah.
So here on GitHub,
if you just look at the Layer Labs repo in general, there's like constantly new ones being added. So recently I added a HATS protocol AVS template. So if you want to experiment with like HATS protocol, which is wonderful for like governance, and you want to make HATS that like you have to do some off-chain action to be eligible for the hat, or like, there's a ton of, there's a lot of examples. In the Waves demos examples, there is a AVS controlled safe account. There is a prediction market example. We're really trying to make as many examples as possible. And if people want to help make examples, like DM me, I don't know.
Hell yeah. So the Waves NFT, this is the one we just looked at. This, I'm going to be the first person to star that. Let's go. Awesome.
Yeah, I think we're gonna make the Waves NFT one really cool. It's kind of lame right now. I was hoping to get farther with it today, but we're gonna add IPFS upload to it, which was in another branch. We're gonna add image generation with like stable diffusion running deterministically. I don't know. We're gonna like make it a really cool, fun example for people. And we have some actual AI like art projects that are looking to use it. So it's gonna be fun.
And then here in Awesome Waves, it's a very extensive like just repo of all types of resources. And it's pretty cool to see that you all have all of this stuff on day one in terms of like the official like announcement day, that there's so many resources to kind of start out with. Because I think a lot of times, again, in this space, what you see is people like announce and launch with something that doesn't really have all that much there, but there's a lot to work with here. In fact, you could probably spend days, weeks like diving into all this stuff. So
yeah, we keep building the craziest stuff. Someone built like a Telegram bot example. There's like so many things you can do. It's just like it's a really bold new world.
Awesome. So this is the first day that this is kind of like going out in terms of the docs and everything. What are the plans for Waves over the next few months?
I think mostly just builds like our initial community and make some real apps for people. Like, I think that I'm tired of waiting for like real things using AVSs, and I think we can get there like sooner rather than later. And so I believe that AVSs allow for like making the next generation of great protocols. Like when we allow for people to like have decentralized protocols that are able to verify off-chain data, or I mean, you talk about this stuff all the time on your channel. I don't need to rant.
No. I mean, I like to hear other people's perspective and kind of just underscore the potential there. I think it's something that people don't really understand maybe a lot of times.
Yeah, and I think that's where I want to get to next, which is like working to make some very fun examples, some of which are like art projects and stuff. And we want to make things that people have never seen or experienced before. Like I remember living through a DeFi summer, and like every other week there was like a really crazy, awesome new protocol and new mechanic, and it feels like things have gotten like really stale. And I think that we are on the cusp of like AVSs being able to unlock whole new types of incentive systems. This is actually one of the main focuses we're working on with Waves right now is rewards, which is also in conjunction with EigenLayer, because we want to be able to make AVSs that are economically viable and offer people rewards for restaking and running them. And But we think also more broadly about rewards. Like AVSs are amazing for building really complicated incentive mechanics. Imagine you want to build an incentive system that like takes into account like user activity across many different chains, or even some off-chain activity, right? Currently, you see this just in like points programs or whatever, all run with like centralized servers. But I think that, you know, the next meta is going to be a new era of like incentive mechanics that are made with these like, you know, AVS technologies that we didn't have previously. So,
Oh yeah, I mean the design space is incredibly big, and I think a lot of people do and have understood the potential for building in this way, and that's why we have hundreds of teams building, you know, an EigenLayer. But the barrier to entry is just very high. You know, you kind of have this, I would say, resource constraint for doing something where, like, when you kind of like really just lower the barrier to entry to building anything in any developer platform, you kind of just expand innovation because there's less risk. Like if I can try to experiment with something and it takes me one day, the risk to doing that is almost zero. But if I need to spend 2 months or 3 months, I'm taking like this opportunity cost, right? So I think waves and better abstractions like reduce the opportunity costs for experimentation, and therefore kind of unleash more innovation and more experimentation, and therefore more value. So that's kind of the way I look at this, and I'm really excited that you guys are launching today. So
yeah, no, it's the birth of an era. I don't know. It's also just the first thing that we're launching. It's not the only thing. We're just warming up. So
hell yeah. Well, this has been really great. If someone wants to become part of the Waves ecosystem and learn more and kind of connect with all of your team, what should they do? And yeah, maybe will you all be showing up maybe in person in the next few months at any events or anything like that?
yeah, we're gonna have some like amazing parties at Berlin Blockchain Week. I don't know if those are gonna be open to the public, but we'll definitely be at Berlin Blockchain Week. It'll be great. I think the best way for people to get involved is just go to wavs.xyz. We've got a Telegram group there. There's links to the Twitter. There's links to the docs. There's links to the GitHub. There's links to all the examples. wavs.xyz. I think that's a great place to start. And then I think we're definitely like always looking for people that are like hungry to try out like cutting edge technology for like the first time. Like there is a lot that you can do with Waves, and it's hard to even scratch the surface of it. There are multi-chain triggers. There are like, you can compose components together. So one component runs and then another one runs and then another one runs, and then you get a result on chain. Like these are very, very powerful things. And we're like really looking for people that want to like actually like build some real apps with them. I'm very particularly excited about like new incentive mechanic use cases and like governance use cases as well. One of the things that we are looking to use Waves for is to make things like liquid democracy and stuff like that, which wasn't possible in a pre-AVS world.
Super interesting stuff there. Definitely the composability aspect is a lot there as well. So do you all have an example of what that might look like already written?
So
yeah,
that's coming out in the next release of Waves. So right now we're on the 0.3.0 release, and we're moving to 0.4.0, which has like so many good things. It's hard to describe, but the main thing is with that is also going to come docs for the multi-chain triggers, which are actually already in the current version, but not very well documented. And there will also be testnet support. So you're going to actually be able to run against like whole sky testnet with like actual Eigen contracts. And yeah, there's going to be a bunch of other good stuff in that, including Golang support, experimental TypeScript support.
Ooh, TypeScript support. That's cool. I like Rust and TypeScript the most. So
yeah,
yeah.
So yeah, it's going to be, there's a lot coming out, and you know.
Cool. Yeah, and you'll be hearing a lot more from me as well, and the EigenLayer account will be sharing stuff as well. So
yeah, maybe next time we can get like Reese on the channel, who's like an actual, you know, he's one of our rock star devs, and you know, we could do a much more fun example.
Let's do it. I'd love that.
Like multi-chain example.
Awesome. Let's do it. Okay. That's awesome. Well, thanks so much for your time and everyone that kind of came by and watched our stream. I'm going to be linking to all of the docs and everything in our YouTube channel. I've already dropped the docs below here on the Twitter stream as well, if you want to kind of go and take a look. So thanks for watching and thanks for your time, Jake. If you want to see more Infinite Layers, we'll be back this week with the third episode of Infinite Layers in 1 week, which is the most we've ever done. Bye,
Cool.
everyone.